Hello, good day. Welcome back to another math video. This day we'll be talking about characterizing the roots of a quadratic equation using the discriminant. You can still remember our quadratic formula was the form of x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. And again, a, b, and c are the coefficients and a should not be equal to 0. Now in this quadratic formula, b squared minus 4ac is called the discriminant of the quadratic equation. Now you might be asking, what is a discriminant? When we are talking about the discriminant of a quadratic equation, it will determine the characteristic of the roots of a quadratic equation. Meaning to say, by simply having the value of the discriminant, we can actually identify whether the roots of the quadratic equations are real and unequal, imaginary and unequal. So again, the characteristics of the roots will depend on the value of the discriminant. So if our discriminant is equal to 0, in other words, b minus 4ac is equal to 0, the roots of the quadratic equation will be real and equal. If it's greater than 0, it will be real and unequal. If it's less than 0, we will have an imaginary and unequal roots. So to better understand these concepts, we'll have some example. Example 1. We are asked to find the discriminant of each quadratic equation and then state the characteristic of the roots. So we'll have this first equation, 2x squared plus 3x is equal to 20. Notice that our equation is not in standard form, so first thing that we should do is to express this one in standard form. So to do that, we will have 2x squared plus 3x minus 20 is equal to 0. Why do we need to express our equation to standard form? For me, it's a bit easier for us to identify our a, b, and c if our equation will be in standard form. Next thing that we should do is to identify our a, b, and c. In this example, our a is 2, our b is 3, our c is a negative 20. So after identifying our a, b, and c, we will substitute that one to our discriminant formula, which is equal to d is equal to b squared minus 4ac. So we will substitute b is 3, a is 2, c is a negative 20. And then we will have 3 squared is 9, negative 4 times 2 times negative 20, that is 160. 9 plus 160, that will give us 169. Now remember that if our discriminant is a positive number, our roots will be real and unequal. So we'll check this one by solving the roots of this quadratic equation. So let's call our calculator to solve for the roots of this quadratic equation and see whether they are really real and unequal. For those who haven't watched yet our video on using the scientific calculator in solving the quadratic roots, I'm suggesting to watch that one first and then go back to this particular lesson. So in our calculator, we will simply input our a, b, and c. Our a is 2, so we'll have a is 2 equals b is 3 equals c is a negative 20, and then click equals. To find the roots, we'll click equals again, and then here we go. The first root is 5 over 2, and the second one is negative 4. As you can see, 5 over 2 and negative 4 are real numbers and they are unequal. Therefore, our solution is correct. So the roots of this equation are real and unequal. We'll have example number 2. Again, express this one in standard form. We will have 9x squared minus 3x plus 2 is equal to 0. And then identify our a, b, and c. Our a is 9. Our b is negative 3. Our c is positive 2. And then we will substitute our a, b, and c to our discriminant formula. We will have d is equal to b squared minus 4ac. We have negative 3 squared minus 4 times 9 times 2. That will give us a negative 63. And again, looking back to our rule earlier, if the value of d is less than 0, the roots will be imaginary and unequal. So to check that one, we'll be using again our calculator to see whether the roots are imaginary and unequal. So in our calculator, we will input a is 9, b is negative 3, and then c is equal to 2. Click equals. As you can see, this will be our roots. Both are imaginary and both are unequal. Therefore, the roots are imaginary and unequal. We will have our last example. The equation is negative 2x squared minus 8x minus 8 is equal to 0. There's no need for us to express this one in standard form because it's already in standard form. So we'll proceed in identifying our a, b, and c. Our a is a negative 2, our b is a negative 8, our c is also negative 8. So we will again substitute our a, b, and c to our discriminant. D is equal to b squared minus 4ac. Negative 8 squared minus 4 times negative 2 times negative 8. That will give us 64 minus 64, and that will give us 0. Again, looking back to our rule, if the discriminant is equal to 0, therefore our roots will be real and equal. So we'll check that one using again our calculator. Our a is a negative 2, our b is a negative 8, and our c is also negative 8. Click equals. Our root is negative 2, and that is real and equal. So does it mean that we only have one root? The answer is no. Again, remember, when you are dealing with quadratic equations, there will always be two roots. So in this case, it just happened that our roots are both negative 2. So there are still two roots, but again, based on the discriminant, it's real and equal. So that is how to use the concept of discriminant and identifying the characteristic of our roots, whether it's real and unequal, imaginary and unequal. We'll see you in our next video.